Okay, here we go. Welcome to the deep dive.
Hey there.
You brought us some really interesting source material today. And our mission, as always, is pretty simple. Jump right in, pull out the key stuff, and help you get up to speed fast.
Yeah, and today we're looking at these excerpts from a YouTube chat on Sequoia Capital's channel. It featured Hanson Wang and Alexander Mbirikos from OpenAI's Codex team.
Right.
And they're talking about the future of software development. It's quite a deep dive itself.
It really sounds like it. Because they're painting this picture that feels, well, potentially revolutionary. We're not just talking about AI helping write code line by line anymore.
No, not at all. It sounds like it's moving way beyond that. The idea is AI actually, doing the coding for you.
Down there for you.
Yeah, they laid out this vision that's much bigger than just autocomplete. They're talking about autonomous AI agents, agents working on their own like virtual machines in the background.
Wow, okay. And you mentioned they tease something kind of wild about the future interface, not your standard IDE.
Huh. Yeah, well, they threw out this provocative idea, maybe not entirely serious, but it involved something looking maybe more like TikTok than VS Code for reviewing agent work.
Okay, that's different. Definitely grabs your attention.
It does.
So our goal here is really to unpack what this evolution of Codex actually means, how it's changing software development, and, what's the real impact for anyone building software or even just curious about where AI is going practically.
Exactly. Let's maybe start with the original Codex. A few years back, 2021, I think, it made a big splash. It was the engine behind GitHub Copilot, right?
Right, Copilot, I remember that. So that was mostly autocomplete, like helping you as you typed.
Precisely. It was reactive, sitting there suggesting the next word, the next line of code, working with you.
Okay, a Copilot makes sense.
But the shift they're talking about now is towards something much more proactive, these autonomous coding agents.
Autonomous agents. So you give it a task, like fix this bug or add this feature, and it just goes off and does it on its own.
That's the core idea. They really emphasize this shift from the pairing model AI side by side with you to a delegation model. You hand off the whole task.
You did all these.
You delegate, and the agent works independently in the background, often on its own sort of virtual computer setup.
That sounds like a massive workflow change.
Yeah.
And they also made a point about these agents being specifically tuned for, like real-world coding, not just contest problems.
Yes, that's super important. They contrasted it with models like, say, GPT-3, which might be amazing at competitive programming puzzles. Codex, they said, gets a lot of extra training, specifically reinforcement learning.
Like learning from feedback, trial and error.
Exactly. To get good at the messy day-to-day stuff you find in, enterprise development, the goal is producing code that's actually mergeable.
Mergeable, meaning it's code you could realistically add to your main project.
Pretty much. Code that follows the conventions, passes tests, hopefully, has decent comments or descriptions. It's about learning the taste of professional software engineering.
The taste. I like that. So it's not just logically correct, but it fits in. It feels right to another developer.
That's the idea. They talked about putting a ton of effort into training it on things like code style, how to write good pull request descriptions, making sure tests are written and actually pass.
They had that analogy, didn't they? Comparing it to...
Yeah, the precocious competitive programmer versus the experienced engineer. GPT-3 might be the brilliant kid who aces contests, but Codex is being trained to be more like someone with years on the job who understands teamwork and practicalities.
That clicks. It gives it that job experience. So when people start using these agents, what are those moments where it really hits them? The aha moments.
Bug fixing seems to be a big one. They gave it as a prime example. The agent can just go off, try to reproduce the bug, figure out the cause, and propose a fix, all on its own.
And wasn't there a specific story? Sounded pretty intense.
Oh yeah, the 1mm Lottie animation bug, the night before a launch, classic scenario. An engineer basically just described the bug to Codex and let it run. Well, it took 4 tries, 3 failed attempts. But the 4th one nailed it, provided the exact fix they needed to ship. That's a serious aha moment. Saved the day, basically.
Absolutely. Getting unstuck like that when the pressure's on?
Yeah.
Wow. What else makes users go, aha?
The other big thing they mentioned is what they called the abundance mindset. Because you're delegating tasks, they run in the background asynchronously. You're not blocked.
Right. You're not just sitting there waiting for one thing to finish. You can multitask.
Exactly. Or rather, parallelize. Users realize they can just kick off like 20 different tasks, maybe even 50 in a day or an hour. Explore multiple ideas at once.
Okay, so instead of thinking, should I try A or B, you say, agent try A, agent try B, agent try C too.
Precisely. You just farm out the work. It totally changes how you approach problem solving and iteration.
That could seriously change a developer's day-to-day, which leads to the obvious, maybe slightly scary question.
Yeah.
If agents are writing more code, what happens to the human developer?
Yeah, the big question, their take is that the role shifts. It becomes much more about reviewing the agent's output.
So quality control, oversight.
Kind of. And they're putting effort into making that review process easier, making the agent's work transparent.
How do they do that? Like, what makes it easier to review?
Things like showing you the sources the agent consulted or the actual terminal output from when it ran tests or tried to build the code. It gives you context, helps you trust the output. It's not just a black box spitting out code.
Doing its work, basically.
Yeah.
That makes sense. They also had that point about how engineers actually spend their time, right? It's not all coding.
Exactly. They estimated that maybe only 35% of a professional engineer's time is spent literally writing code.
Only 35%. What's the rest?
Well, thinking. Ideation, design, planning, talking to people, validating solutions, deployment, maintenance, fixing things, all that other stuff that goes into building and running software.
Okay, so the coding is just one piece of a much bigger puzzle.
Right. And the vision seems to be let the agents handle more of the automatable grunt work, which often is the coding part, or repetitive fixes, and let humans focus on the harder, more ambiguous stuff.
Like the upfront design, the complex problem solving, the things that need creativity or deep understanding.
That seems to be the direction. Become more of an architect, a reviewer, a strategist, tackling the really tough challenges that agents can't handle yet.
How does that start? Is it gradual?
They mentioned an iterative approach. Initially, developers use the agent to speed up their own coding. They review the output, push it, their team reviews it like normal. But the vision extends further to agents helping with planning, maybe even proactively flagging and fixing issues.
And does this open the door for like non-engineers to contribute code? They mentioned something about a product manager.
Yeah, they talked about that possibility. A PM using Codex to make a small code change without needing to interrupt an engineer. While the main focus now is definitely professional devs, they absolutely see the barrier lowering. More people could potentially contribute directly to code bases.
Which brings us back to another big one. Does this mean fewer software developers are needed in the future? Or more?
Their opinion, the one shared in the conversation, was pretty strong. The number goes way up.
Way up. Why?
The argument is that if you make building software dramatically cheaper and faster, you unleash this massive pent-up demand for bespoke software. Custom tools for specific teams, niche businesses, things that aren't economical to build today.
Ah, so instead of everyone using the same few big apps, you could have tiny custom apps for everything, tailored perfectly.
That's the vision. Software becomes much more personalized and ubiquitous because it's so much easier to create. So while one engineer becomes way more productive, the total demand for software explodes, needing more engineers overall. It's a multiplier effect.
Interesting take. Okay, let's peek under the hood. What's actually powering this? Still GPT-3.
It's based on GPT-3, yes, but the key is that extra layer of reinforcement fine-tuning. That's what gears it towards professional software tasks. But it's not just the model. The whole training environment is a huge challenge.
Why? Because real code is messy.
Exactly. It's not like textbook examples. They talked about dealing with code bases that have no unit tests, for instance. The agent needs tests to check its work. So they had to figure out how to create realistic, sometimes messy, training environments.
Right, mimicking the real world. And the environment the agent runs in is also crucial.
Hugely. They stressed using the same containerized environments for training and deployment. It avoids that nightmare scenario of, well, it worked on the agent's machine. Consistency is key.
Makes sense. Now, these agents can run for a while, right? Up to 30 minutes on a task. What are the hurdles there?
Yeah, the longer tasks present different challenges. From a user perspective, it's hard to specify a complex 30-minute task perfectly up front. Often you don't even know exactly what the final result should look like when you start.
So defining the task clearly is hard. Finding the right level of detail, the granularity.
Precisely. How do you make something that works for a tiny one-line fix and a massive refactoring where you have a detailed plan and something exploratory where you're just trying things out? That's a tough design problem.
Do they offer any tricks for handling those bigger tasks?
Yes, a good pro tip. Ask the agent to generate a plan first.
Ah, okay.
Before it dives into the code, get it to outline the steps. You can review that plan, maybe tweak it with the agent. It's often way more efficient than trying to get the initial request perfect.
Like briefing someone before they start a big project.
Exactly. They use the analogy of working with an intern. Sometimes you give them a big task, and they might come back and say, this is a bit much right now, or get stuck. Breaking it down helps.
That intern analogy is helpful.
Mhm.
Okay, looking further ahead, how do we actually interact with these things? What does the UI look like? Is it just ChatGPT?
Well, the ChatGPT interface is kind of a research preview for the delegation model, but the long-term vision is much broader, more ubiquitous. It should blend pairing and delegation.
Ubiquitous means
Yeah.
everywhere.
Yeah, basically. Not just in one app. The idea is you should have access in your IDE, in your terminal, maybe even in Slack or your error monitoring tools.
So wherever you're working, you can just ask for help. Or maybe the agent proactively suggests something.
That's the dream. Maybe an error pops up and the agent has already started investigating before you even see the alert.
And OpenAI's approach with ChatGPT as a sort of central hub plays into this.
Yes, that's central to their strategy. They don't really see a future of lots of separate, specialized agents you have to juggle. They envision one main assistant ChatGPT that can call upon different skills, like coding, browsing, analyzing data.
Like having one teammate who knows how to use a browser, a terminal, a calculator.
That's exactly the analogy they used. ChatGPT orchestrates the specialized tools, like Codex for coding.
So what happens to our current tools, like IDEs? Do they go away?
Probably not go away, but definitely evolve. The focus shifts. Less time spent manually typing code, more time spent reviewing agent suggestions, planning architecture, designing systems, validating the results.
More high-level work.
Seems like it. They also touched on how to make existing code bases more agent-friendly. Agent-addressable, they called it.
Oh, yeah. What helps the agent understand your code better?
Interestingly, it's mostly stuff that helps humans, too. Using typed languages, having small, well-defined modules, writing good tests, these all provide signals the agent can use.
Good practices are good practices, for humans or AI.
Pretty much. They even mention using unique searchable names for projects, like their internal code name Wham, so the agent could easily find relevant documentation.
Ah, that's clever. Thinking about the wider market, how quickly do they see things changing?
They use the word crazy pace. They reckon the software development tool market will look completely different in just 2 years. The big shift, they believe, is moving beyond just IDE integrations towards these agents working in their own environments.
And that review cycle agent codes, human reviews become central.
Absolutely. Managing that higher volume of generated code is a huge challenge for everyone. They mentioned even internally at OpenAI, they're figuring out norms for how to handle agents generating multiple attempts at a fix and how teams review and choose the best one.
It's a whole new workflow to figure out. Now, towards the end, they did that lightning round. Any quick highlights stick out?
Let's see. Recommended reading. Ina M. Banks' Culture Series for a Positive AI Future View, and Richard Sutton's Bitter Lesson about Scale in AI. Favorite apps mentioned included Linear Integration, Wimo, Copilot.
Yeah.
They're bullish on robotics, big prediction. 2025 as a breakout year for agents across many categories, not just code.
Agents doing lots of different things.
Yeah, and they seemed most excited about generalized agents like ChatGPT getting access to multiple tools, browser, code execution, etc., rather than just single-purpose bots. Back to that central assistant idea.
Got it. Wow. Okay. So if we pull this all together, the main takeaway feels really clear. AI for coding isn't just getting better, it's fundamentally changing how it works, from helper to doer.
Yeah, from Copilot to autonomous agent. It's less about tweaking tools and more about reshaping the entire process of building software and even, what it means to be a developer.
It really impacts the tools you might use or build and just the nature of technical work itself.
Definitely.
Which leaves us, and you listening, with a pretty big thought to chew on. If these agents take over more of the coding, the grunt work, and maybe even start suggesting what needs doing, where do you fit in? What's your unique value?
Right. What are those human skills, the planning, the design, the critical review, the communication that become even more crucial?
And how do you actually learn to leverage these incredibly powerful new tools effectively,
Right.
rather than just being replaced by them? Something to think about.